Good afternoon, everyone. I am Quoc-Bao from Pukyong National University. Today, I would like to present our recent research work, damage monitoring in pre-stressed concrete anchorage using Raspberry Pi platform sensor system. My speech will cover introduction, objective and approaches, impedance-based method for strength breakage monitoring, Raspberry platform impedance sensor system, stand breakage monitoring using Pi, and finally concluding remark. Introduction. Simply, structural health monitoring is the process obtain local and global responses via sensor, extracts damage feature information of structure. Next, quantify damage severity, and finally diagnose structural health status. Using piezoelectric sensor is a good way to monitor local damage. However, conventional impedance analyzer is big, heavy, and even hard to apply in practical field, so we need a portable impedance monitoring system. So, the objective of this study is to develop a portable Raspberry Pi platform impedance sensing system for strength breakage monitoring in pre-stressed concrete anchorage. Our approach, firstly, to outline impedance-based strength breakage monitoring technique, then to develop a Raspberry Pi platform impedance sensing system, then finally, to experimentally evaluate the feasibility of our system for strength breakage monitoring. This slide shows the impedance-based strength breakage monitoring technique. As you can see in figure 1 top left, when the force F change leading to a change in structure intensity, then as a result change in impedance signature, then we use change in impedance signature for damage quantification. As you can see in the figure 2 top right, this is the 2 degree of freedom impedance model, one for PSD interface and one for Anchorage. In the figure 3 bottom left, that is the electromechanical impedance. So I'm not gonna go to detail in this. Next to the figure 4, that is important that we use the damage index, the road mean square deviation index to quantify damage based on the change in impedance signature before damage Z and after damage Z star. And we use the upper control limit to alarming whether damage occur or not. This slide shows the Raspberry platform impedance sensor system and Pi. As you can see in figure 1 top left, first, this is schematics of proposed system, including a Raspberry Pi impedance board with 895933 impedance converter and her PCT sensor. The Raspberry work as a computer board to control 5923 to get the impedance response from PCT sensor. The Raspberry work with a power of 5 voltage E to C integrated circuit protocol to communicate with 5923. By exciting a voltage at the predetermined frequency to PCT sensor, the system can be receive a impedance response at frequency band. Below is the prototype Earth. This slide shows the specification of Raspberry Pi platform and Hioki 3532. As you can see here, the Raspberry Pi is more cheaper, low weight than the Hioki, and our system has some advantages like able to connect to other external devices, work with many computation protocol such as etc API etc, and then finally that can be support communicate wirelessly to other identity devices. This is the calibration procedure and result. As you know, the original signal collected from the LCO pi have different shape and magnitude. However, this signal has a peak at frequency band similar to Hughes system. Then, so the calibration procedure were made to adjust signal. The calibration procedure includes four main steps. The first is collects original data. Second is calculate magnitude, gain factor, and phase. The third is calibrate magnitude and phase width based on the signal from the heel key. And finally, extract the correct impedance response. As you can see below, the figure below shows calibration result of real imagery and phase impedance. Only in this study use the real impedance to quantify damage. This slide shows the experimental setup of Prestressed concrete strand breakage monitoring. The bridge to simulation intact, 9 strands were tension to 11 turn in the Anchorage. The APCT sensor was glued on the anchor. To simulation damage, the strand 1 and 6 were released to 0 turn. Then we use the SEL pi and Hue key measure impedance at all PCT interfaces at the inter-academic cases. The cable will be tensioned by hydraulic jacks, and the size of Anchorage will be shown in this slide. This slide showed the experimental result of strand breakage monitoring under strand breakage strand 1 as shown in this slide. As you can see here, the impedance response of a PCT sensor that's similar peak position between two systems, although magnitude of the peak were a bit different. Below, impedance feature of a PCT sensor were illustrated with white bar chart. The IMT index were over UCL and the highest is PCT1, indicating that the damage occurred at strand breaking at strand 1 and strand 1 will detect damage. This is another strand 6. The impedance response of APCT sensor were quite similar in peak position above. although magnitude of the peak were a little bit different. As you can see below, the figure show the impedance feature of APC, um, while the bad charge. You can see, as you can see here, the RMFD index were over UCR and the height at PCT6, uh, which mean the damage occur and strength breaking at were detected at strength 6. This is concluding remark of this work. Based on the analyzed result, some concluding remark can be drawn. First, the proposed system works stable BRD with all herpicity sensor in damage monitoring. Second is the system achieved the accepted accuracy in impedance signature correction. Although some analyzed the results from proposed system were a little bit different from Hyuki 3532, the strength breaking was still detected. And the future study remains to investigate the effect multi-strength breakage. And also, we also investigate the effect of temperature on the signal measured from the pulse system. Thank you for your attention. If you have any question, please contact Professor Johnny Kim or even me via email. Thank you.